Hi, Year 11. We're back for Booklet D. It's called C on here. I've crossed it out and changed it to D. It is Booklet D. It's all our shape work that is more likely, if not 95 to 100% certain, that these topics are calculator paper topics. So be aware of them, but I wouldn't go over the top revising them for paper 1. Although I think there are some certainties in paper 2, okay? Pythagoras theorem, trigonometry, definitely something on similar shapes, be it similar area, similar volume, and definitely a sine, cosine, or area of a triangle, one at the end of the paper. So lots of marks in this booklet. Make sure you're really, really happy with it, or use other websites that you're aware of to kind of get extra questions to help you if you don't feel these are enough. I've put on the front the contents page. Just one thing I've written on mine is that in the Pythagoras and trigonometry questions, if there's any link to area of a triangle in these, because we're looking at right angle triangles, I think the understanding here is that you would use base times height divided by 2. Possibly you need to work out the base or the height using your Pythagoras or your trigonometry, that kind of thing. And there's an example of both those in there. In this section, in this little video, we're going to look at the first 4 things here: Pythag, trigonometry graphs, and if there's time in this one, we'll do spheres, cones and pyramids, and then we'll pick up the A and A star things in the next video. Let's get into it. Okay. First thing I've written in my Pythagoras questions. A Pythagoras question is where we're given 2 sides of a right angle triangle, 1 and 2. But importantly, we're asking, the question is asking us to find the missing side, the third side, okay? So right angle triangle, 2 sides given, third side needed. I'm not going to talk about the first 2, okay? A little bit of practice for you. 1, finding the hypotenuse, finding the big side, square, square, add square root, and 1, finding the small side, square, square, subtract square root. I haven't even done the calculations down here, I've just given you the answer. Check you get to the same answer as me. This one, very quickly, anytime that it talks about the diagonal of a square or the diagonal of a rectangle, that's basically a line that joins one corner to the opposite side top corner, okay? Basically splitting your square or rectangle into 2 right angle triangles, hence where Pythagoras can come in. In here we're told the perimeter of this square is 76.4 meters, so the 4 sides add up to that, so I've quickly divided that by 4 to work out that each side is 19.1 centimeters. Then I've used square, square, add square root to find the length of this diagonal. I've given it to 1 decimal place, actually came out to be 27 or 27.0 centimeters. The only one that I was going to do with Pythagoras was the 3D one. In this we're asked to find the length of AG. Okay, AG is this line here from the top front to the back bottom right, okay? So it's kind of running through the rectangle there. Now, the triangle that I thought it was part of, okay, was, if I go this direction, G to A, down to E, and across the floor of the cuboid, back to G. So triangle AEG. In triangle AEG, I know the length of AE. I don't know the length of EG. So at the moment, I'm not able to work out the length of AEG. However, this missing side that might help me here, hopefully you can see rectangle EHG and back, EHG. I can get the length of EG using these 2 numbers and by doing square, square, add, because this is the hypotenuse, add square root. Let's quickly blast through that then. So, using triangle EHG, square, square, add square root, okay? 7 squared first of all, 49. 3 squared is 9. Add them together is 58. And then take the square root of 58. Now, you can work that out. We've got a calculator. We didn't in the numeracy papers when we did this, but we have this time. However, I'm going to just leave that as the square root of 58 and put it onto my diagram as that, a little bit like we did last November in numeracy. I'm now looking at triangle GEA, or AGE, or EGA, whatever you want to call it, just use those 3 letters. And again, I'm going to square, you find in the hypotenuse, so I'm going to square square, add a square root. The square root of 58 squared, the square root of 58 times the square root of 58 is just 58. 5 squared is 25. Adding together again is 83. And the square root of 83, this time I can't leave it as a square root, so I get my trusted Casio. Square root button of 83 equals, to one decimal place, 9.1 centimetres. Okay, let's flip over, or pause there if you would like. Now let's go. Nothing to say too much about this last one. It was one to do with finding the area of the triangle, base times height divided by 2, but we didn't know the base. So I've used here Pythagoras' theorem to find the base. I get that to be 28, if I'm correct. It looks good because the hypotenuse is 35, a little bit bigger than 28. And then I've used base times height, 28 times 21 divided by 2, and got the answer 294 centimetres squared. The following part then asks you to work at the volume. So we've got the area of the front of the prism. We've just got to times that now by the depth. The depth is 2 metres, bit naughty. These are in centimetres, this one in metres. So I've changed 2 metres to 200 centimetres and multiplied my area from part A by the 200 to get 58,800 centimetres cubed. Okay, on to trigonometry. Again, I've made a note up here. Okay, this time we might be given 2 sides again. But if we're asked to find the third side, it's Pythagoras' theorem. If we're given 2 sides of a right angle triangle and asked for the missing angle, or we're given 1 side and an angle and asked for another missing side, that's trigonometry. So it's something to do with an angle. Either we know the angle or we want to know the angle. The kind of method, write out SOHCAHTOA, label, cross out what you know and what you want to know, draw the little triangle that corresponds to the one you're going to use, and then apply it. Okay, you have a look at that one. I'm going on to this guy here. In my first triangle, well, my long-term goal here is to find angle x, but I just don't know enough about this triangle at the moment. I know that the opposite of x is 15, if you can see that on your booklet. But I could do though in another side really to find angle x. So the one I'm going to try and work out first of all is this here, which is the hypotenuse of this triangle here. So, quick label using a triangle PSQ. If this is the angle I'm given, this is the opposite. Okay, this is the hypotenuse on this triangle, therefore this is the adjacent. What do I know? Well, I know the angle is 38, cross out SCT. I know the opposite is 8 centimetres, cross out O. There are 2 sides left. The one that I'm interested in knowing is the hypotenuse, so I'll cross out H. So in this case I'm using so. S for sin, or sine theta, O for opposite, H for hypotenuse. I'm finding the hypotenuse, and it leaves me with the sum. Hypotenuse is equal to the opposite, 8, divided by S, but we must remember S stands for not just the angle, but sine of the angle, so sine 38. The calculator, put that in brackets. Again, trusty calculator, over you come. 8 divided by sine 38, close the brackets on the 38, equals, well, to one decimal place is 12.99, but to one decimal place that would actually be 13.0, so we'll call it 13 centimetres. Okay, now that we know him, if we consider the second triangle, on the second triangle, you are no longer the hypotenuse. Okay, in fact, you are the opposite. You are the hypotenuse, so you are now the adjacent. So it's the adjacent that we now know to be 13 centimetres. Okay, this time we'll cross out SCT because we want to know the angle. Okay, we'll cross out O because we know the opposite, and we'll cross out A because we've recently worked out the adjacent, and we'll leave the hypotenuse because we don't know it and we don't want to know it. This time I'm using TOA. Alright, T-O-A. I'm using it to find the angle, cover the T. So T, which stands for tan theta, they've used X, I prefer theta, is equal to O, the opposite, 15, divided by the A, 13. Quickly work that out. 15 divided by 13. Don't round too much here, okay? We'll leave rounding until the end. So whereas I can't write the full answer here, I'm going to go to 4 decimal places. 1.1538. 1.1538. So theta is equal to tan minus 1, the inverse tan of 1.1538. You might be slightly different to me if you've rounded differently, but again, I wouldn't round too much until that final answer. So we'll go shift tan 1.1538 is 49. Again, I make it 0.1 to 1 decimal place degrees. Okay, that's that. Let's turn over. Again, I'm just going to leave this for you to pause and have a look at. Okay, hopefully you can see that answers there. Again, I like drawing out the separate triangles. So you've got 2 right angle triangles here, part A and part B using different ones, and the same here. Okay. And then I've left this one just to do quickly with you. This one is another one where we're talking about area. Okay. In triangle, if you can see it from there, in triangle ABD, we're told the area is 35 centimeters squared. We know that the base, I know it's been rotated, but the base of that triangle is 5 centimeters. We could do it though in the height, which is the length from D to B. If we can work that out, we'll then know these 2 sides, which will help us to work out angle X using trigonometry. Okay, so base times height, 5 times the height divided by 2, base times height divided by 2, and it's got to be equal to 35. Now, you can do this as trial and error, or you can use your algebra skills, okay? I'm going to use algebra, so instead of dividing by 2, I'm going to move that divide by 2 up there. It becomes 35 times 2, which is 70. So 5 times h is 70. So h is equal to 70 divided by 5, which I make to be 14. H is 14 centimeters. I've already pre-drawn this triangle down here. The difference now is I now know this length, which is 14 centimeters. Okay, so what do I know? I know the hypotenuse. I don't know the opposite, but I now know the adjacent. So I've ended up crossing out car, which is what I'm going to use, CAH. Drawn it there. I'm using it to find the angle. Cos theta is equal to the adjacent divided by the hypotenuse. That is 14 divided by 32. 14 divided by 32. Again, don't be stingy on decimal places at this moment. 4375, and cos minus 1 of 0.4375 is... and I make that to be 64 degrees. Okay, we've probably got time on this one just to do one more section, your trigonometry graphs. Okay, so let's have a look at these. Now, you've either got to learn what these look like off by heart, or be prepared to draw a little table and put in your x values, which are normally like multiples of 90, 0, 90, 180, maybe minus 90 and so on. Put those in instead of x, and work out values, which will hopefully just be a reminder. Let me give you an example of what I mean. I'm going to start with ones that we've done, sine and cos. So I'm going to start by drawing for you this one up here, y equals sine x, but for values from 0 to 360, so 0, 90, 180, 270 and 360. I've drawn a little table and I'm just going to take the sine of all of them. So sine of 0 is 0, sine of 90 is 1, sine of 180 is 0, sine of 270 is minus 1, and sine of 360 is 0. So what this does is when x is 0, it's 0. When we go to 90, it becomes 1, then comes back to 0. At 270 goes down to minus 1 and then comes back to 0. Can't get away with straight lines with trigonometry graphs. It's got to be like smooth curves. It's almost like a wave, this one. Okay, so I have to turn my paper on something. So a wave up right, then I wave in the other direction, so I've kind of got a hill, then I've got a valley coming here, right, looks like that, and if we kept going in either direction, you'd see that pattern just continuing there. Let's go and draw the cos one first of all. Slight difference here, we actually have to draw it from minus 180 up to 180, so I'm coming both sides, so I need to go minus 90 and minus 180 this way, and then 90 and 180 that way. Let's start with cos this time, and let's start with the minus 180, and it tells me that's minus 1. Cos of minus 90 is 0. Cos of 0 is 1, then back down to 0 and to minus 1. So where do they go? So here we're down at minus 1. We come up to 0, we go up to 1, back down. Now it looks almost like it wants you to draw like a almost two edges of a triangle, but we've got to remember this is a smooth curve. It would be nicer if we could have kept going, you would have seen it, but we're coming out of the valley and into the mountain, back down the mountain and into the valley, so you've got to kind of remember that shape, okay? We'll draw the tan one in a second. Your part B's, right? Find all the solutions of the following equation in the range 0 to 360. Sin x equals, so the answer to this has to be minus 0.8. Now minus 0.8 is around there. Okay, if I take a red pen and draw a line across, badly because I don't have a ruler. Okay, I'm kind of looking for two solutions here, which are there and there. But I can use my algebra skills as well to kind of find one of those, hopefully. So if sin x is minus 0.8, x is equal to sine, I take the sine over, sine minus 1 of minus 0.8. Really quickly. Shift sine minus 0.8. Again, I'm on the calculator, apologies. Which is minus 53. Or minus 53.1. Possibly I should. Go on, we'll give it to one decimal place. Now that's not one of those, and the reason being, if this had kept going, it would have looked something like that. So that is coming from there, okay? That is minus 53.1, but that's not in the range. The range of answers I want are these to this side of the y-axis, not that one. However, if that gap from there to there is 53.1, then that gap from there to there is the same, as is the gap from there to there. So my two answers here are 180 plus 53.1 and 360 take away 53.1. 233.1 and get this right, 306.9. Again, correct me if I'm wrong. At any point leave comments below this as well, and I'll get back to you as quick as I can if there's any problems. Alright, the same thing here, I'm tempted to not do this. Cos x is minus 0.19, so it's approximately there. Again, I'll use a red pen, but the two answers I'm looking for are this one and this one. If I drop it in my calculator, okay, x equals cos minus 1 of minus 0.19. Okay, shift cos minus 0.19. It is 100, well, basically 101 will do me. So u must be 101, so this one, using the symmetry of the graph, must be minus 101. So my two answers are 101 and minus 101, really quickly before my timing runs out on here. Okay, the tan graph, if you put these values in, right, tan minus 180, it says it's 0. This one says error, then 0, then error, then 0. I'll show you this in a revision session. However, what this looks like, okay, is the zeros markers are there, there, and there. It never ever gets to these lines here. So if you draw a line down, that might help you see it. And again, I'll explain this at another point. But this guy does that. Then he starts down there and he curves into 0 and then away, but never touches 90. then it starts again, and if I kept going, that would have kept going that way, and I guess that would have kept going that way. So that's your tan graph. Maybe best to learn that one off by heart. And finally, I've done these two for you. If you want to pause the page now, you can use that, and hopefully they make sense to you. Maybe just the plus one, notice what's happened there, just the cos graph has moved up one. So instead of -1, 0 and 1, it's 0, 1 and 2 are my points. Take a look at that. And I'll see you for part 2 of the video. Bye bye.